We've seen some properties of logarithms in the previous section, and now we'll just look at some more, the product rule, quotient rule, all these. But what I've done first is I've just given you a review of the properties that we saw earlier. You need to keep these in mind because they'll come into play here in this section when we work with these new properties. So just keep these in mind. You want to recall these. And remember when we talked about these, we said if the bases match, then they cancel out. Remember the A and the A match, so they cancel out, and the answer was X. The E and the understood E was there. They match up, they cancel out, so the answer was X. Same thing here. Bases match, they cancel, answer is X. Bases match, they cancel, answer is X. So now let's look at some new properties. We'll use these properties when we're expanding logarithms. So we may be given a logarithm in a format where it's the log of something that's already combined, like the log of two things that are multiplied, the log of two things that are divided, or the log of something that has an exponent located on it. So we'll see these properties that will allow us to kind of expand or split these logarithms up. So let's look at the first one. If it's the log of something multiplied, then this property says we can take that multiplication and change it expand it into two logarithms, the log of the first plus the log of the second. When we're dividing, the properties say we can take the log of the top minus the log of the bottom piece. Then finally, if we have an exponent, then this property of logarithms states that we can drop that exponent down in front to expand or kind of simplify our logarithms. So let's take a look at using these properties in the following examples. So let's start off with this one. I'm noticing that the operation here is 10 times x. So if there's a multiplication, this property says we can split it up by taking the log of the first plus the log of the second. So I can write the log of the first plus the log of the second. So it'd be log base 4 of 10 plus log base 4 of x. And that's all we can do. Just take care of that multiplication by splitting it up with addition. Multiplication will split up with addition. Let's look at the next one. Here we see this division. So division is going to be split up using subtraction. The log of the top minus the log of the bottom. So here I'll take the log of the top minus the log of the bottom and just choose the log that's already there. Here I chose log base 4. Here I'm choosing the log that's there, ln. So log of the top minus the log of the bottom. So division splits up with subtraction. Now here I want to investigate this a little bit further because there's something I notice that I can reduce or simplify. Remember the understood base on ln is an e, and here comes in the properties that I wrote on the above on this sheet, just recalling those properties that when the bases match, they cancel out. So I see that situation happening here. The bases are matching. They will cancel out. So I'm left with just 3. Always look for any reduction using those previous properties. So 3 minus ln 7. They're going to want you to reduce these as far as you can. Let's look at this one. I don't see anything obvious, but here is a big thing you need to remember. Always convert roots to exponents. I've got this square root here, and I know that a square root is the same thing as a 1/2 exponent. So I can write the square root of x plus 1 as x plus 1 to the 1/2. Noting this exponent, or noticing that exponent, would follow this property over here. When you have a log of something raised to a power, we can drop that power in front of the logarithm. So what I can do is take this power and drop it in front of my logarithm. So it would be a 1/2 log base 4 of x plus 1. Now that x plus 1 can't be split up because it's the log of something added. The only logarithms we can split up are the logarithms that have the log of something multiplied, divided, or an exponent. I can't split up that addition. Let's do a few more. Log of 4x to the 5th power. I notice there's an exponent there, so that exponent is on the whole thing 4x, so I can drop that 5 in front to get started. So that would give me 5 log of 4x. Now I notice that's the log of something multiplied. What I can do is I can take that multiplication and split it up with addition. So that means it would be the log of the first part plus the log of the second part. But there's that 5 in front, and you've got to be very careful that since that 5 was an exponent on the whole 4x, that 5 has to be included as part of the whole thing that you split up. So the 5 actually goes with the log 4 and the log x, and I believe when you're working in the exercises, they're going to want us to distribute that to get 5 log 4 plus 5 log x. So notice what we did first. We dropped the exponent, and since that exponent was on the whole thing 4x, when I split the 4x up, that 5 that was dropped in front is going to have to go with both pieces. Let's take a look at this one, noticing again that we have a radical that needs to be converted to an exponent, and the exponent for a cube root is a 1/3. So let's rewrite that with the proper exponents. Log base b of x to the 4th, y to the 1/3. So that's the log of something multiplied. And how do we split up the multiplication? We split that up with addition. So it would be log base b of x to the 4th plus log base b of y to the 1/3. As our last step, there's no more multiplications, no divisions to split up, but we do have those exponents that can be dropped down in front of each of those individual logarithms, giving us a final expanded result: 4 log base b of x plus 1/3 log base b of y. Okay? And let's finally do this last one. I've got the log of two things that are divided. So division, if we look on the previous page, division is split up with subtraction. So that division is going to come down and split up as a subtraction. So I'll have log base 5 of the square root of x, but I'll call that an x to the 1/2, minus log base 5 of 25y cubed. So notice I took the log of the top minus the log of the bottom. And I'll investigate and see if there's anything else that can be split up, and I notice that there is a multiplication right here that can be split up with addition. So log base 5 of x to the 1/2, I still have this minus that's going to drop down, and then this will split up as a log base 5 of 25 plus log base 5 of y cubed. Here's an important thing. Since the 25 and the y cubed were both at the bottom, and I split those up, this subtraction actually goes on both of them, so I need to enclose that in parentheses, which will remind me that I'm going to have to distribute that negative or that subtraction. Be careful with that. I'm splitting this up, but since there are two pieces at the bottom, this subtraction goes with both of those pieces when I split it up, so this subtraction is going to have to distribute. Well, let's distribute the negative, and let's clean this up all in this step. Let's take the 1/2 down in front of the log. It'll be a 1/2 log base 5 of x. Let's distribute the negative, so I have a minus log base 5. And remember, keeping in mind those very first properties, 25 is the same thing as 5 squared. Distributing the negative to the second part, minus 3 log 5 of y. Why is the 3 in front? I just went ahead and dropped it in front of its own logarithm. One last step to clean this up, and I'm just going to take this middle right there and clean it up, knowing that log base 5 of 5 squared is 2. The final result, the expanded version, will be 1/2 log 5x minus 2 minus 3 log base 5 of y. Watch out for those exponents that you have to convert, and watch out for those parentheses around quantities in the denominator or quantities in a set of parentheses that an exponent may apply to. So we see the properties, we've used them to expand. We've just used these properties to do some expanding. Now all I've done is I've taken the exact same properties and I've written them in a different order, and we'll use them to condense. So we'll kind of do the crawfish method. We'll go backwards. We'll take these results that we have here and try to go backwards and get it back into its original state. That's the aspect of condensing. So this says if you have two logs that are added, then that means they were originally multiplied. The two arguments were originally multiplied. If you have two logs that are subtracted, then those two arguments, m and n, were originally divided. And if you happen to have a number in front, then that number in front was originally an exponent, and just bring it back to its exponential position.